Welcome everybody. This is the first webinar we've had in a while, right? Sadly so. And we always end each one with saying, see you in 6 weeks. Let's see if we can be better in the future. Today, usually we do have like 1 hour of just straight up Q&A, but we were thinking after the last release we were going to talk a bit more about security testing. There's a lot of people using it. It's kind of a new area for us and for our community, and there's been like a lot of questions back and forth. So we said let's sit down. Ulla did this presentation in Arlington.
Arlington, yes.
Yeah, and we said let's show it to everybody, to you. And well, should we get started? With
Sure.
us, we've already said, I'm Nicholas.
I'm Magnus. And I'm Ole.
The
Three Stooges.
And not in pictures, Dennis as well. Dennis will, well, if we misbehave, he'll throw stuff at us. Okay, I'm going to switch to you, Ole.
Yeah, sure. Go ahead. Okay, thanks, Nicholas. So I'm gonna do a slightly modified version of the presentation I did in Arlington a couple of weeks ago, and we came up with this really catchy title together, right? Didn't we? I think it was actually Dennis who has the credit for that. Better safe than Sony. So let's talk a little bit about Sony, right?
Yeah. Should we go back to? Because that's a good point.
I'm sorry.
No, it's a good point. I forgot about it. Apologies, Sony. We know that you are our customers, and we didn't mean to insult you. I think most people understand that this was not about Sony, of course. It's about security, but it can happen to Sony. It can happen to, you have some examples later on, government agencies. It can happen to everywhere, like it has.
God forbid.
Yeah. It's just, yeah, but it's just SH that happens to you. And poor Sony, we love you, and this is, of course, you were klutzes to let it happen, but that's another issue. But it can happen. The point is, you have like these highly skilled security people that still just can't keep it together, and that's what happens.
That's what happens,
Mm-hmm.
exactly, and that is what happened to Sony. I think it was like in April, May this year. So in case you missed the story, Sony was attacked with a pretty simple SQL injection attack, which allowed the hackers to expose sensitive data about Sony's users, over 1 million users. And the database, since it wasn't even encrypted or secured in any way, it was out in the wide open for all to see. And just as you said, Niklas, this can happen to anyone. It's happened to Nokia, it's happened to MySQL, it's even happened to Lady Gaga, as far as I know. So, I mean, no one is safe, obviously.
Not even the lady. That's horrible.
So, the thing here is that this is the security attacks and threats are easy to underestimate and ignore, and it can really happen to anyone. So I'm not going to talk that much more about Sony, but I'm going to talk about soapUI, of course, and and how to do functional security testing with soapUI, and I'm also going to show you how to automate those functional security tests. And I'm going to be, as you know, both soapUI and Hudson are free tools. The open source, you can download soapUI from our website. Hudson is from Oracle's website. I will be doing some demos. I will be using soapUI Pro for those, although it's not a requirement to use Pro. You can do all the stuff I'm showing you with the free version, although it's easier to do it with the Pro version. I'll get back to that. So, the first question is, what is functional security testing? And I mean, when it comes to a hacker that wants to attack your system, there are a number of layers that he or she can attack when trying to do something malicious. So if you can look at this not very beautiful picture here, A malicious attack first has to go to the network interface, then it's somehow handled by the operating system, which forwards the requests to the application server, and then the application server forwards the requests to the actual application. And the first three layers here, the network interface, the operating system, and the application server themselves, are all perfectly valid and popular targets for security attacks. And those are not really covered by the functional security testing, because functional security testing is, for us at least, is related to vulnerabilities that are a consequence of the functionality in your application. So you might have a shopping cart, and while working with that shopping cart in the middle of the transactions, there might be a security hole when it comes to updating the shopping cart. And that's very, very tied closely to the actual functionality of the service, and not so much to the actual infrastructure that carries it out. So that's how we define functional security testing. And once again, soapUI is targeted at only that. And if you're really serious about taking security to the next level for your applications, you need to consider all these levels, and you need to consider a lot of other tools than just soapUI. So the hard part, so the question we asked ourselves, so okay, we know that there could be vulnerability during the execution of our transactions. So how do we detect them? And or how do we test for them? The model that we came up with, maybe not too surprising, is that basically we start with a functional test that you already have in soapUI, where you perform a number of actions, requests, whatever, to validate the functionality of your service or services or APIs. And then on top of that, you layer what we call security scans. So, and these security scans would be after those steps that you decide, here I need to check for vulnerability. They would basically perform like SQL injection or an XPath injection or XML bomb or whatever vulnerability you want to check for at that point. So that's basically how it ties to the actual functionality, and it's a pretty important point. So when executing a functional security test in soapUI, basically you're executing the functional test itself, and then on top of that you're running the security scans. So you might have a transaction which is 10, 15, 20 requests, where you want to test security first after the 12th request, and you would run your functional test, all those requests through, and then after you've put your system into a certain state, that's when you want to check, okay, are we sure that we're not open for some kind of vulnerabilities here? So that's the model we've been working after for trying to help our users to detect security vulnerabilities in their applications. The hard part is actually, or one of the many hard parts is here to how, if you do, if you attack your system to try to provoke some kind of vulnerability, it's not always that easy to actually know if you've succeeded. Many of the attacks that might be performed could be silent. Basically, the response you get back doesn't really tell you anything about that's something wrong, or you have to know pretty well a lot about your system to understand that this response I'm getting is actually not the response I'm supposed to get, and it does indicate that there might be something wrong. Fortunately, it's not always hard, and I mean I think the most obvious effect an attack could have is a denial of service. Basically, that whatever you do makes the service unavailable. It crashes. Whatever it does, the service is no longer available, and that's of course very easy to detect. The more subtle ways to detect could be that the request you're sending is not really expected by the service, so it doesn't handle it in a good way, but still throws an error message or some kind of error response. And if you're not, if you haven't configured your system correctly, that error response might give the attacker a lot of information about your system. It might be showing what database you're using, what version of the database you're using, how you're accessing your database, anything that a hacker could use. So they might know, okay, you're using that version of the operating system, that version of the GDBC driver, that version of this database. That's enough information for them to look in all the publicly available directories of known security issues, and that's something they can use to start digging into your system. So what we call sensitive information exposures is basically something you really need to be aware that in the public API you should be very, very careful about exposing any information. And the problem here is that often when you build your systems, and by default they're configured to give you a lot of error information, because when you're developing you want to know what's going on. You want to know that it's part of the database or whatever, but then when you move that into staging deployment you forget to turn that off, and then you can see this on the web pretty often you get an error and it tells you everything about stack traces and servers and everything, instead of just giving you the 500 server error message, which is from a security standpoint probably better than a more verbal, which gives you more details of the actual system.
And the problem is the most common 404 page contains information about what web server you're using. Web server version.
Yeah, so you should be really careful, and I mean, depends on how paranoid you are, but even HTTP headers can usually expose what server, sometimes they expose what server you're using and things like that. You might even want to turn that off just to be really sure. And then, of course, there might be an attack-specific way to determine the outcome. I think we'll get back to that, especially when it comes to SQL injection or other types, or cross-site scripting attacks, where you know that this attack, if it succeeds, will give me this type of response, and then I need to check for that. One hard part here is I think we had a good question on that in one of the people who signed up, is if you're configuring how your tool asserts if there is a vulnerability, you don't want to get a lot of false positives. You want to be sure that if the test says there might be a vulnerability, you really want to be sure that there is a vulnerability, so you don't get a bunch of reports that you hand over to others and people get scared for no reason. And I think this boils down to that you have to know, you have to be pretty knowledgeable about what you're doing when you do security testing in the end. You have to, it's not something that you can just turn on and all will be fine. It does require a little bit of you to understand, what am I testing, why is this a security, why could there be a vulnerability here, etc. And also when you're configuring the configurations in soapUI or whatever tool you're using to detect if there has been a vulnerability, you need to be really trying to narrowing down that as much as possible, so you don't get false positives, especially if you automate your tests, so you don't get unnecessary warnings. Yes. So the most common attacks, there is an organization, OWASP. You can go to their website. They have a continuous monitoring, and it's a great website and resource where you can see they have a top 10 list of the most common security vulnerabilities, and all the vulnerabilities are very well described, how you can protect yourself against them and all that kind of stuff. I think the current state of the list, at least when I checked last, is that the injection attacks, like SQL injection, XPath injection, anything like that, are the most common ones, just like the one that Sony was prone to. Cross-site scripting is on the second place, and I'll talk a little bit more about that. And the third one is broken session authentication management, and this is how you manage sessions, that you don't reuse session IDs, that you don't expose, when you manage sessions, that you don't secure that information so others can hijack them, etc. I'm not going to be talking anything more specific about that, because that's usually something that's handled at a higher level, like at the application server level, so not as part of the functionality of your application. It might be, of course, but I'm not going to talk more about that. I think check out owasp.org and you'll learn a bunch of stuff.
It's a good site, and it's
a great resource.
Great resource, and we can't say enough good stuff about the OWASP people.
So, one of the questions we got is actually, why did we add security testing? And the reason was pretty obvious. It's because you asked us to. We had a survey, I think it was 2 years ago now, where we had asked our soapUI users what functionality they wanted most, and security testing was the top #1 requested feature. So that's why we added it to the tool. And the philosophy behind how we add security testing is a little bit like we did with load testing in soapUI initially. We know that we can't, it's not a do-it-all tool. We can't do everything. But it's really, our goal is to make our users aware of the fact that it's really of the security aspect of their services, and to give them a tool which makes it pretty easy for them to at least check for some very common security vulnerabilities and threats. And hopefully that will somehow, just like with load tests, what you can do in soapUI is pretty basic, and it can get you started, and then you can move on to a much more advanced tool like LoadUI. Or if you're in security, and there are a lot of other great, both free and commercial tools out there for doing much more elaborate security testing. The important thing here is just to get people to start thinking about security, because Sony didn't, and I know a lot of people out there don't. It's like when you talk about this, it's well, that doesn't happen to us. So it's just something people don't ignore because they're not exposed to the kinds of problems.
Yeah, and since these are the tests we're supporting are kind of like the 10 most common attacks, at least you have some decent sense of security after doing the security of your web service after doing these tests, and that's what we wanted to aim for, right?
Yeah.
Just
it's like a sanity check.
Yeah.
Yes, sanity.
Check. Yeah, and
sanity, security.
Yeah, and then it's a good point, and the awareness. And so how I already see that I'm talking far too much. So how does it work in soapUI? So the as I was already hinting at it when talking about the general functionality. So basically in soapUI you have your existing functional tests, and in those tests you usually have a bunch of requests. SOAP request, REST request, HTTP request, JMS, whatever. And what soapUI now 4 allows you to do is create security tests on top of those functional tests. I'll be showing you. And for all the parameters, so those that you want in your requests, you will be able to try to send malicious or content that could somehow exploit or provoke errors that are security rated on the server. And then also give you the possibility to assert, to check for if that's actually the case. So that's basically the model. I'll be showing you in just a little while. So. And the attacks, the security scans that we focus on, just like you said, Niklas, are the most common ones. So there's SQL injection, XPath injection. There are a bunch of attacks related to invalid and malicious input, like malicious attachments, malformed XML. You can have fuzzing attacks. Well, I'll show you a little bit of that later as well. Also, there is some support for trying to detect cross-site scripting attacks, which is pretty complex. And there's also, in the true sense of soapUI, a script security scan, which means that if you're good at Groovy scripting, you can basically script together whatever scan you might want to. And the protocols you can test here is any requests basically in soapUI that are parameterized. So soapUI XML-based requests, REST, HTTP REST, so if you want to test a website or a REST service, AMF, which is also parameterized. You can test JDBC. I'm not really sure. I mean, testing for a SQL injection in JDBC might not be the best case, but you could, if you're like calling stored procedures, you could perhaps there check, do invalid input to those kind of tests, just to be sure. I think that's
one. And also, would you can use it if you have like attachments saved as a blob in the database, and you just want to make sure that it doesn't end up in the database. That's where you can check. So if it's in the database, it's actually pretty horrible. Maybe you don't security test it, but you need it for the
And I mean, I think once you get into the mindset of security testing, I think you're going to get a lot of ideas that how you could test your specific system apart from what you can do with the built-in security scans. And I think if we help you to get that far, then I think we'll be really happy and proud, because that's where we're going to get to make you aware of the whole security aspect. So enough general talk here. So let's talk about the SQL injection. And to be honest, I mean, the main reason that SQL injection actually works is that people are sloppy coders. And because if you code your web page or web service in a sloppy way when it comes to database access, you will be prone to SQL injection attacks. I'm going to show you an example in just in a minute. But what it means that if you do it that way, then basically you could let the hacker execute any SQL or database SQL statements against your database, which is what happened to Sony. And I mean, if you haven't set up security right, the user maybe that's being used to access the database maybe even has the rights to delete all the database schemas, everything. So this is a really, really important thing, and it's a very common vulnerability also. So it's something that you really, it's this thing that you kind of think, oh, we're using this pretty modern framework, or this pretty modern, we're doing like with using especially if you're using the latest, hottest technologies, you should be a bit careful, because that's usually where things are hot. Maybe they haven't matured enough to be very security aware. So, and also we had a question about this. The SQL injection is usually database agnostic, so this is not something that happens at the database. It doesn't matter if you're running Oracle or MySQL or Microsoft or whatever. This is something that's very strictly related to the SQL statements that you're executing. And one pretty hard part with SQL injection is that it might be really hard to detect if you're actually prone to SQL injection, because running some kind of SQL, if the request you're running doesn't return a response that somehow gives an indication what happened in the database, then it's really hard to know, did this actually do something in the database? And then you would have to check it by other means, which you can of course do with soapUI, with some other tool. So I hope some of you out there are as knowledgeable of SQL as well as we hopefully are, as the hackers of Sony were. I'm going to show you a really simple example of how this works. So let's say you have a login page. This could be a website, or it could be SOAP or REST or whatever, where you use this really simple SQL query to validate the username and password. So basically we're going to check, is there a user in my database that has this username and password? So if the user enters Bob and fish, the actual SQL query being executed against the database would be select star from TV user, where username is Bob and password is fish. And if there is such a user with that password, you would get a row back, and then probably your system would say, yeah, this is a valid user, and generate session ID or something. And if there isn't such a row, you wouldn't get any hits, and then the login would be failed. The thing is here that the code basically just took what was entered in the name and password fields and inserted it into these two fields here in the query. So basically a string concatenation. So here comes evil hacker number one, and what he puts into the username and password is username is still Bob, but the password is this a little bit cryptic string here. And if we put that into the context of the resulting SQL statement, you will see that it's going to ask, get me every from the TV user where username is Bob and the password is empty, or 1 equals 1. And as you probably know, 1 will always equal 1, at least as far as I know, which means that this will always return all the rows in the database, meaning that you will basically always be able to or it will at least return all the rows where there's a username Bob. You will always get a login, a valid login, even if you don't know Bob's password. So this is a really simple way for someone to totally bypass this kind of authentication based on a SQL statement. And when you see this, you say, oh, wait a second, now I get it. So you could probably add a semicolon in here, and then after that start adding some more SQL statements like delete or whatever, truncate or whatever you want to do. And if the SQL state, when you're building that SQL statement, concatenating it and running against the database, if you don't do any kind of validation or parsing, then that will have free reign to do whatever it wants to. And you might think, we don't do that. We don't make these kind of mistakes. I think that's probably what Sony thought as well. So I think you need to be really sure. Okay, enough talk. Let's have a look at the soapUI a little bit here, if I can find it. It's right here somewhere. Here we go. Okay, so this is soapUI 4. It's a snapshot version, I guess. I have here a simple test case, which basically just does a login, transfers the session ID that it gets from the login, and then does a logout. So I'm just going to run this, and it goes so fast so you can hardly see anything happen. So now we're going to add a security test, and we can have a look at the actual login request, which is basically just a username and a password. And the response that we're getting back is just the session ID. So what we're going to do is we're going to do a SQL injection, and we're going to try to run all those injections on these username and password fields. And in our case, what we don't want to happen is that we don't want to get a session ID back, because that would mean that the login has actually succeeded when we don't want it to. So let's just create a new security test. And there's different versions here of this wizard. I'm just going to create an empty security test. And I'm going to add a SQL injection scan to the login request. And I'm going to use this little wizard here to extract the actual parameters. So it finds the password and username parameters in my SOAP request. And that's where it's going to insert all those evil SQL statements. You can see here all those SQL statements that we found on the web when we tried to do research on how to do this. So these are all the strings that soapUI will send to try to provoke, and you can of course reconfigure those and add your own. There's nothing here that will delete your database or anything like that. This is just pretty easy stuff. And then, as I said, we need to assert that we actually failed the login. So we're going to add a standard XPath match assertion, which is, if you know about soapUI functional testing, way of asserting. So what I'm going to say here is I'm going to have to modify this a little bit. So what I'm going to check here is I'm going to count the number of session IDs in the response, and the response I want back is 0. I don't want there to be a session ID. I'm getting one now since it's using the last request I ran for this login, which had a session ID since it was a valid login. So I'm saving that. I have my XPath match here configured, all ready to go. I hope I didn't forget anything. That's it. So now I'm going to run my test. And as you can see now, it ran. Sorry?
Carol had a point. I should have been more attentive. And, well, tell me again when you show a small pop-up window. She couldn't read what was in the window.
Oh, I'm sorry. I'm sorry.
Yeah.
I'm sorry. I'm a bit too fast here, I guess. So basically, I ran the test now, and what this did now is that it ran the actual login request, and then it reran the request and tried to inject all those malicious SQL statements first into the username field and then into the password field. And then the XPath assertion checked if we did get a valid session ID back, which we did for this first request here, which used the exact same SQL injection I showed you in the presentation. As you can see, the comparison failed. It expected no session IDs, but it did get a session ID back. Unfortunately, and the same thing happened when that SQL was injected into the username field as well. So both the password and the username fields were prone to this SQL injection attack. So you can see here, I guess we can click here. So this is what the actual message looked like, what was sent. This was admin, and this was the password that was sent to the system. And the response I got back was actually a valid session ID. So that's just a really simple way of showing you how this can then be done. Then, of course, in the standard soapUI way, you can create a report, print that as PDF and all that kind of stuff. The reporting is only in the Pro version, as you might know. Okay, so that was the first security test I wanted to show you, just with a very simple SQL injection attack. I'm going to come back to soapUI in just a little while, and we'll do some more security attacks. Okay. So now we're just going to walk through a bunch of attacks which are very related to sending bad data. I mean, SQL injection was also bad data, but this is more like trying to provoke errors that are related to validation and not handling out-of-bounds data and things like that.
Mm-hmm.
So
yeah, so SQL injection is you have this bad data that you yourself has said this is bad data. I want to give it to this potentially web service.
yes.
Fuzzing and the other stuff is any bad data.
Yeah, it's any bad data, exactly.
Yes.
Fuzzing is
so interesting. I think fuzzing, when you look into it, it's funky.
yeah, it's pretty cool. Fuzzing is basically you basically spam your service with more or less randomly generated input. There are pretty cool GUI fuzzing tools out there, which basically you give them a desktop application and they will generate random mouse clicks and key presses.
Yep.
And you'll be surprised to see that most applications will crash sooner or later because they're just not prepared for that kind of handling.
It's like when I use any
Oh,
software.
I mean, yeah, it's like you're so fast. Yeah. So here, when you do this, you want to make sure that your system can really handle just random input, and in soapUI you can set it to run for over a weekend, millions and millions of requests, and just set like some kind of ranges for how long, or how to randomize the input, and just to see if you can provoke anything. I mean, why not, just to make sure. And here what you would probably expect from the service is either just to show an error message that this is bad input, cannot handle those, just say throwing an error, not expect. If we go to invalid input, it's kind of the same thing, but here you know a little bit more about what you're doing. So this could be related to if you have a date field, you expect a date, but the user actually supplies a floating point number or just a string which isn't a date, or if you're expecting a weekday but you're just getting a number, or all those kind of invalid data things.
Yeah.
And the boundary checks is similar. If you're expecting a value between 1 and 100 and the tool and the user sends something outside those bounds, well, how does your system handle this? And you could say, well, what can go wrong? I mean, it'll throw an exception, but if we get back to what we talked about, the thing about exposing sensitive information, usually if you don't think about this, the default exception messages generated by your system might just expose information about your system that once again a hacker could use to exploit some other vulnerabilities. So the least thing you can do is make sure that your system doesn't like tell the user more than it should if you do something, send invalid input.
And this, I think this is a more common problem for web services than for just normal web, for example.
Yeah.
You just throw an exception because, well, it's just an exception.
Yeah, exactly. I mean, a lot of nowadays you have like client-side validations in web forms and then really fancy.
Yep.
That doesn't mean you shouldn't also validate on the server, because a hacker is not going to use the form to attack your server. So he's going to be using some tool, not soapUI of course, to do those attacks. So you need to validate, of course, on both ends and not rely that the hacker will be entering data in the way you want it. Malformed XML is another variant of this. So here we're moving kind of. This could be malformed JSON as well. I mean, any formatted input to your system where you break the formatting rules of that language syntax and making sure that the server, the parser on the server, can handle that in a way that doesn't once again expose information. You can create invalid XML structures. You can just have structures that are valid but not in line with what the server expects. There's a lot of variances here. And as a sidekick to this, you can have XML bombs. I'm not going to show you an XML bomb here, but it's in soapUI. XML bomb is basically exploits some special features in XML that could result in, depending on the server's configured, could result in the server trying to expand entities in more level, in a very high recursive level, so you get out of memory errors and probably denial of service errors on the server. So soapUI has tests running those. I'm not going to show you those right now. What I'm going to show you though is we're going to go back to soapUI. So I'm going to close this security test. Let's just create another security test here. And now we're going to use this, sorry?
Just zoom in.
Zoom in, you want to zoom in here?
Oh, yes. I'm like completely busy chatting with the chat room. If I could do that full time, I'd be happy. So I think you can see better now.
Okay, yeah. So
And
this
this
is the...
was for Carol, who had problems before.
Be prepared getting... So I'm going to use this
Will do.
with the wizard here. I mean, this is one of the features in the Pro version. So the wizard here allows you to basically step-by-step add those security scans that you want to your security test. So we're going to do a boundary scan, fuzzing scan, invalid type scan, malformed XML scan. We're not going to do boundary scan because the username password fields that we have in our login don't have any boundaries. They don't have, well, they have a string type, which is basically anything, but just for the sake of it, I'm going to add it. Next is I'm going to do it for all the parameters. I'm going to do it, yeah. So I'm going to add this sensitive information exposure assertion, which is basically an assertion that we've added that uses a pretty large, we put quite a lot of effort into this actually, list of regular expressions that it applies to the response to try to detect if the response contains some kind of information, version information about your database or web server structures.
And of course all this stuff, the validations are, they're not, you can edit them yourself if you want to. So
yeah, if everything in the true soapUI way is configurable. So I've run, so you get this nice summary in the end, and I'm just going to run finish here, and now I need you to zoom out again.
sorry. There we go.
So basically now it's generated a security test where you can see it'll do a fuzzing scan, invalid type scan, and malformed XML for both the login and the logout. And I'm going to go to do a little bit modification because I know the fuzzing scan by default takes a lot of time. I'll just run it like it was.
Yeah, that's the spirit of the fuzzing scan, is just run it for a long time and see what happens.
You can here once again for the invalid types. You can see here what data it tries. soapUI will try to send to. Thanks, Magnus. To provoke like type errors that aren't as expected. So I'm just going to get this test running here. And here you can see it's running now, and you can see that here the username and password, the values that it's been generating basically randomly, just to see. I mean, of course it could by chance generate the actual username and password, although it's not very likely. So while this is running, let's see, this takes a little while to do this. So it's going to run through this, it's going to run through all these the 3 security scans I configured for both the login and the logout request. And since it takes a little bit of time, we're going to go back to the presentation and we're going to jump back and look at the results in a little while. Here we go. Yeah, so cross-site scripting is one thing I want to talk a little bit about because it's pretty popular. And there are popular, so it's pretty common as a security vulnerability. So there are 2 types of cross-site scripting, what you call the persistent and non-persistent scripts. And I'm going to show you an actual example of a persistent attack. Let's first have a look at the picture here. So this is a non-persistent cross-site scripting attack. Is basically if you know that if you have a web application that somehow if you send it a script, it will return that script and present it to the user in a way that it will allow the script to execute on in the user's browser. That's how this can be exploited. So basically, if you could be receiving a mail that it looks like it's from Amazon, and saying, click here for this to use this offer, this coupon code, and when you click on that code, you get, this was actually a malicious attempt. So the link contains some kind of script that you don't see, which is then uploaded to the server that you're calling Amazon or whatever website. And if there's a security vulnerability, the website will return that script as part of the response. And then the script will be, if it's done badly once again, executed in your browser. And then that script could do a lot of harm. It could basically stay silent in the background, record your cookies, make requests back to some kind of host, and do a lot of spying and damage on you that you're really not aware of. So as you can see here, the user has some kind of link which includes this malicious script, so content, submits the link to the application, gets the result back, and then which has side effects in the browser, which could be doing some kind of harm. I think the persistent aspect of cross-site screening is probably the more serious one. And the funny thing, when I did the presentation in Arlington, just an hour or two before that, I got an email from the provider we have for our bug tracking system, saying that you need to upgrade if using the latest version. We've discovered a persistent cross-site scripting vulnerability in our system, so please make sure. So this is something that's also not that uncommon. And it also relates a little bit to what Niklas was talking about, saving binary data and malicious attachments. But basically what happens here is that you have an API where you insert some kind of data into a system, and that data is then later presented to a user in a web interface. And if the parsing or the presentation of that data is not done in a way that's some kind of security aware, you might be exposing those users to security risks. So you might, a malicious user once again might insert a script. I'll show you just how that could look. Or if we're talking about attachments, they might insert some kind of malicious files. And then on the other end, if for example this bug tracker, you could in the description field, you could insert a script there, and then when some other person would look at that issue, and then the description would be unescaped in the client, and the script would be executed. So basically the script then could be doing whatever harm it would like to do. So this is really tricky, and so this is also more, it affects a little bit more. The first one is mostly related to web interfaces, but here this can be any API that you use to enter data into a system, SOAP, REST, whatever, where in the end the data is presented in a web interface. So here once again you need to be aware of what's going on and validating the input and making sure that you're not doing anything unsecure. So we'll have a look at that. Let's see. Yeah, this test is done now, and thanks. So you can see. So this, what you can see here, the fuzzing scan and the invalid types didn't have any alerts, but the malformed XML did have a bunch of alerts, and we can see here in the log that we're getting a stack trace, and this is one of those sensitive information exposure, which says that there was a stack trace found, and this can give hackers information about your system. So if we double click here, we can see that the response message was indeed something that could have given hackers quite a lot of information. They could see this long exception stack trace here. If hackers, they would probably be able to figure out, okay, they're using this software on the server, etc., etc., and from that maybe exploit some kind of vulnerabilities. Okay, great. So now I'm going to show you a short example of cross-site scripting. So I have this is usually a bit tricky, so let's see how this works. I have a really simple really simple interface. Let's see if we can make this work. Just a second. I need to restart Firefox here. So I have a really simple database thing on my here where I can enter items into a database, and then I have a web, and I can do that with REST or SOAP. And then I have a web interface where I can list those items, look at them. So I'm here. I'm going to use JSON requests to enter items into my database. And the first request, if you can see this here, it just enters a phone called my phone. It describes as a very secure phone, and it has this cost. I'm just going to run this request. And now I might have to restart Firefox again. Let's just see if we can, if it picks this up. No, this is a caching issue. Sorry about this. It's going to take a little bit of time. We're not in a hurry, are we?
Nope. So
here we can see this phone I entered into the system. We can view it. And so the next thing I'm going to do here is I have another JSON request, but instead of entering a description, which is nice and canny, I have a small script that I hope somehow will be executed on the client side when somebody accesses the web interface for this database. So you'll see what that does. So I've run that against my server, and once again I'm going to have to restart Firefox. At least now I know I have to. And here we have the two items, and now if I, the page which lists the items in the database obviously doesn't have an issue with showing the script. You can actually see the actual script here. But if I go to the actual page that displays the item, there is an error here, because what it does, it doesn't escape the script. It just returns the script as it was entered into the database. Yeah. And as you can see here, the script makes this nice alert and saying you've been cross-site scripted, formatting drive C. So of course this is just a scare.
No, but this was one of the points. I'll go back. It was one of the questions that was asked earlier, where the point was cross-site scripting and web services.
Yeah.
Is cross-site scripting applicable for web services or not?
Definitely. I think definitely the persistent type of cross-site scripting is definitely applicable.
Yes,
to
exactly.
web
I mean, in general, like, since there isn't the site and there is no malicious JavaScript code that can be executed, but you can use it in several steps. Like now, you can actually insert malicious that is then being propagated to a web page. Because most of the stuff we do on a web service is being consumed somewhere.
Yeah.
And that's where you can create damage.
Exactly.
Yeah.
That's a really
So that was the
then.
point. The point was, is it applicable to web service? Not directly as much, but indirectly a lot.
Yes.
And when you come to REST and JSON, a cross-site scripting can actually be pretty bad.
Yeah, it can be really bad.
Yep.
So definitely, I think, and I mean, a lot of applications update databases somehow. So not only do you have to worry about SQL injection attacks when you access the database, you also have to be sure that the content you're entering to the database is either not presented in an unescaped way or validated somehow beforehand. So that was that little example. Okay, so time flies when you're having fun. So the last thing I'm going to talk about here is the actual automation part. And the idea here is, say you set up all these security tests in soapUI or whatever other tool, would it make, we think it would definitely make sense to try to run these in a repeated way, maybe once every night, or maybe, well, as often as you might think relevant. Because although you might think, well, I've checked for SQL injection and I've done this and that, you never know what changes you make to your system or your infrastructure or your whatever you're doing that might somehow have a side effect on the security vulnerabilities in your system. So I think it's really important to have these like as a safety net for just making sure that you're not somehow, when you change the JDBC driver or you've updated to that new version, because you updated the version, you forgot to disable the verbose error logging or whatever, because it happens really, really easily that you make those kind of mistakes. Also, I think we talked about this, you had a really good point. One thing, and I should have said that. Yeah, yeah. Don't look so surprised.
It was a mistake.
No. Is that when it comes to these security tests, and what I've been showing in this is that you might have hardware in your system that is configured to handle these kind of security attacks. Just like when you're doing load tests, you might have hardware that tries to prevent a lot of traffic coming from one single IP number. So when you're running security tests, you have to be sure, at least be aware of that there isn't like a firewall in the middle that has detection mechanisms for some of these attacks, so you don't like bypass them. Meaning that just because you have hardware doesn't mean that you can ignore the security issues on the server. It might be still, because you never know, the hardware might fail and there might be a security exploit in the hardware itself.
Yeah,
so
you will change the hardware, it doesn't have the protection, so.
Exactly, so, things happen.
And we want to be proud of the systems we build.
Oh yes, definitely. So, I mean, I'm going to show you this also, of course. The final thing here. So, yeah. So I have, let me see, I'm going to save this project here. So Hudson is I guess many of you know, a free continuous integration server that you usually use for building, but you can use just as well for running tests. So I've set up a configuration here. So soapUI comes with the command line runner for running your security tests, just like you can run load tests and functional tests from the command line. I don't want that plugin right now. So basically, this is, if we want to look at the configuration, this is a very simple, runs the batch command, and just the reports that generated can be are in JUnit compatible format. So let's just go back to the dashboard and run this security test here. Let's have a look. And here you can see the output coming. As you can see now, it's running the SQL injection test. You can see that failed just like it did when we ran it inside the UI. So this is gonna continue running now for a little while, since it takes some time. So and since I've already talked far too long, I'm sorry about that.
No, you're interesting.
Oh yeah. Well. Oh, thank you. Well, anyway, yeah. That's actually, while that's running in the background, I'm going to wrap up. And I think the really important part here is you should take security seriously and don't think we're using the latest framework, or we're on top of things, unless you really are on top of things. But make sure that you really are, and get started with a tool like this, and also build expertise in your organization. Of course, because as I showed you, you have to know a little bit about security exploits and vulnerabilities and threats and how they work to really be able to test your system in a good way. And it's pretty fun actually to learn, and it's not that hard. Maybe that's one thing why people ignore security, because they think it's hard. It's not really. Now, since there's this fantastic tool that gives you these things for free, soapUI, you should definitely use that as a starting point, and then you will discover much more elaborate, advanced tools on SourceForge and commercial that will help you build even better and more secure systems. And if we have contributed to that, then I think we're really happy. Yeah, that's it. And I guess the questions have been pouring in, right?
They actually have, and I've been trying to save them, and also have had a super nice conversation with a lot of people on the chat room. I'm just gonna, instead of writing, I'm just gonna speak directly to AB or AB, who's asking if we can send a recording of this video. That question has been popping up every now and then. We will try to post foremost, I think, the video on the SmartBear YouTube channel. And you should go there. There are a lot of interesting videos, and they're not all soapUI related. That's it for the recording. We'll put it up somewhere. It's going to go up somewhere, but hopefully it will be on YouTube. So, this was an hour. So everybody who feels tired can go home now, but I have a few questions I wanted to ask, so I'm gonna go through them. Okay, so Stephen Price.
Hey, Stephen.
Hey.
A familiar name, one of Magnus' favorite people in the entire world, I think.
Indeed.
No, I think you talk so well about it. I've never met you, Stephen, or talked to you, but I hear a lot of good stuff about it all the time. So, let's see here. This is just quoting from the chat room, so it might be a bit... I have to go back, because he was talking about... Sorry, Stephen. So let's see here. So here we go. So, Stephen has a similar issue when he wants to send a large request to the server that cannot be handled. Okay, that's fine. We know about that. That's like bomb-like stuff. But the failure is not appearing at the test step level, and he can't capture the error for an assertion.
How is the failure appearing?
Exactly. How is the failure appearing? Or I don't know how to use the assertion, is what he's writing. I can see the error and make a notation in my test description, but detecting the HTTP response fail messages would be helpful to capture. So it's at the HTTP level where it gets the...
There is a new assertion we added, which is the valid and invalid HTTP status codes. So depending on if your server sends a status code which indicates an error like 500, then you could use that assertion. It's called invalid HTTP status codes, I think. But if the server maybe returns 200 just out of pure confusion, but still some kind of error messages, then you could use the script assertion, and there you can access the actual HTTP headers of the response and validate them in any way you might want to. But send us a screenshot if that doesn't help, and we'll try to take it from there.
And there was Sarah who asked about cross-site scripting and how it affects SOAP service providers. And as we said, not directly, but indirectly. Because it's being consumed by something.
Yeah, I think it's like anytime you enter data into a database, you should think what's going to happen to this data later. How is it going to be consumed or used in a later step? And very often, like the data is presented to someone in some other context, could there be an opportunity for an exploit there? So you just have to mentally make that check.
Also, Pradeep. And sorry guys if I'm not answering your questions in the chat room now because I'm reading from an Excel sheet here. So Pradeep asked another favorite. And this is a good point and a good question, good discussion topic. It's the SQL injection. He said that the point you mentioned was with simple SQL statement. However, if you use the stored procedure, would that mean that stored SPs are safer? It's an interesting discussion point, isn't it? Theoretically, it depends, because you do have stored procedures that
concatenates queries. I think it depends on how you build your stored procedures. I'm pretty sure that you can write stored procedure in a way that it is unsecure. I mean, the general recommendation is to use some kind of prepared statements. The aspect when you're calling, either you're making a SQL query or you're doing the calling the stored procedure. So in that situation, you would never be prone to the attacks we showed here. But then that wouldn't guard you from eventual errors in stored procedure.
And I guess it wouldn't be a strong argument for using stored procedure for security reasons. I mean, it's kind of an architectural decision rather than a security. But it's still an interesting question.
It's an interesting question. And of course, what happens if you send the SQL, because stored procedures often takes parameters. What happens if you insert a SQL query into the parameter.
Yeah, exactly. That's the point. So how does how does the store procedure use the parameters? And if it's I guess there are different technologies for that, and in many cases probably it just passes them on as query arguments. It doesn't do like any string concatenation. So in that case, it wouldn't be like prone to those attacks. But I mean, if you do like more advanced store procedure programming, and most databases have like whole languages like PLSQL, SQL, then probably there are situations where this could happen.
Yeah.
But I can't give you any specific
I agree with Magnus. SPs or not, it's an architectural discussion, not a security discussion mostly. But it was a very interesting.
It's an interesting question.
Yeah. Here's Belleman, and this is just because I like this question, again because it's interesting. Who asked, has anyone used soapUI for WCF web services? Because we talk about
a lot of people.
Well, I mean, we can talk about what we're thinking of doing.
Yeah, sure.
And that could be maybe, if you're into that kind of stuff, contact us, right?
Yeah, yeah. I mean, we're planning on, or we're discussing how to support VCF moving forward, and expand on the support basically. Right now, people are using it for VCF, but with some restrictions.
Yeah. And the point is, we're discussing the release after next, so we're releasing the next release in March, and then we discuss or plan, however we plan, let's be honest, we plan, but we might change our minds. We plan to start working on WCF after the next release. But no promises, it's just...
We never know.
And right now we had a discussion, or today actually, talking about which bindings to prioritize in VCF.
So the point is, if you are a VCF guy and you have a lot of opinions about it, contact Magnus, because
we're not
seriously.
We're not the WCF guys.
No, and we're seriously listening to any comments or opinions. One question was, is this pro or open source, what we've seen? And it's all open source.
All this is in the open source version. I used this wizard to generate a security test, and also used the wizard to extract parameters from the actual requests. That is in the pro version. In the free version you have to do it manually, but you can, all the security tests and all the configuration stuff I showed you is in the free version. Also the report I created at one point is only in the pro version. But otherwise, it's on there.
Yeah. Orianelli said, out of curiosity, can soapUI show attacks on several, this is good stuff, on several endpoints at the same time? Like you see 2 failed login attempts on one endpoint, 3 on another, and these could come from the same IP. I didn't understand the last part, but like doing tests against several endpoints in the same security test. It's interesting. I don't think so.
Within the same security scan, I guess it would be.
Yes.
I don't think, then you would have to
use within the same test. I mean, you have different endpoints for different test steps, and then you throw it into security.
Yeah, exactly. So you would basically have to have login requests for the different endpoints, and then have security scans for each. But if you want to have, if you have one login request, then you want to basically shoot it at different endpoints. That would require some scripting, as we say. Everything's possible with scripting, but it's not something that's like there's no checkbox for it. I think it would be, that's an interesting thought. I think maybe it would be great if you could get back to us and elaborate on that a little bit.
Yeah.
So that's a good, interesting input for us.
Yeah.
So I don't have a really good answer on that.
Yeah, exactly. It was interesting. And Deep came back and said he tried the SQL injection with his company's official store procedures, and it didn't work. Depends on what we mean by didn't work.
Didn't get any failures, or?
Yeah, exactly. Because
It's
those
secure,
they are secure.
Yeah.
Yeah, oh yeah, Nelly, and absolutely. He said thank for the answer though, but come back again to the forums or whatever with the question, and we can look into it. Okay, let's see here. Aravind RK, question for later maybe. Do you provide for testing JBoss and related deployed apps?
Well, I mean,
follow up, because it was the test I run in is a JBoss environment with JDBC and Postgres Oracle with a thin client written in JMS, Java Web Services. This
JMS or
JMS. That's
WJ with well, I mean, soapUI is basically for testing, so it's the HTTP-based APIs, and it does have JMS support. So if you can do, if you use the JMS support as soapUI to call your application, then you can of course do all those injections and everything that we looked at just over JMS. That's possible. And then, yeah.
I mean, in general, of course, you should be able to test JBoss. There could be some special, like you said, depending on what
the API. But of course, if you just deploy general Java web services or JAX-RPC or JAX-WS web services or REST services, those you can of course test with soapUI. But it seems to me that the interface, the API here is JMS. I don't know what JWS is, to be really honest. So.
Yeah, I was thinking Java Web Services.
Yeah, it might well be. So in that case, then it's a no-brainer, sure.
Yeah, yeah, we worked a lot with the JBoss guys in the old days.
In the old days, yes, in the 2000s.
Here's one of the questions that came in both during the webinar and also before the webinar, we thought was interesting. Does soapUI has the ability to mark alerts as false positives and generate reports without false positives? Mark the alerts in the results as false positives.
I don't know how soapUI would know if it's a false positive.
Yeah.
So the answer is no, but I think we would need to see an example actually.
Yeah. I think the point with false positives is that you have to. That's a challenge, because like you said before, there's always false positives when you do security testing, and you have to work and reconfigure the tests so the tests ignore false positives.
I mean, it's really hard. I think, for example, if we look at the fuzzing test, I mean, it's possible that the randomly generated input actually is valid. So for the login, you could actually be able to log in. So. And how would you detect that? So you would have to basically modify the algorithm to not include valid username passwords, and that's not possible currently. I can't say there's any good way to do this right now. I think it's a really interesting question, and it would be great to see some more hands-on examples. But I think it boils down. I think I tried to touch on the subject a little bit very early on. Is that when you create your assertions for validating if your security scan has indeed found vulnerability, that's where you have to be try to be as narrow as possible, so you don't get too many false positives.
Yeah.
I think, as you say, there will always be false positives. So I don't see. I have a hard. I'm sorry, mentally, I just can't see how we could get rid of them.
Yeah, and in the reports, can you ignore them? No, because you want to ignore them not in the reports, but you actually want to ignore them before going.
But then how would you know it's a false positive? So I guess I'm sure you have some examples in mind since you asked the question. So please get back to us with that. We can figure something
Absolutely, and do it. You don't have to do it here. You can do it offline, so to speak. It's an interesting
We're always
question. Unfortunately. Nalini, with respect to SQL injections, do people say SQL injections? SQL anymore? Is that just me showing my age?
It's you showing your age. No, it's not.
I think you say SQL because SQL is pretty difficult to pronounce.
Okay, good. Because I don't know if somebody said that to me last week.
SQL?
You're old.
No, I think it's the other way around.
Okay. Okay, let's get back. With respect to SQL injections, is the impact quite serious when we have the binding information in the SQL statements? And will soapUI help to test any vulnerability beyond that?
Read that.
Okay, I'll read that and I'll answer the next one from Austin. Can security scans be run with a test runner? Yes. Easy.
We have that.
Oh. And that's kind of the point, is the ability to run the tests you create in soapUI in headless mode.
When it comes to binding, what I'm thinking of is, when I read this, is prepared statements where you bind parameters and input to parameters, and I think that's like the one recommended way to avoid being vulnerable for SQL injection attacks. So if you use prepared statements where you bind and input like strings to parameters, then you should be pretty safe, as they should. Just like what was the? Can I just see the phrasing of that question again?
And if you're still
that soapUI help testing will be beyond that.
Yeah.
I don't know. I guess that's usually where you. I don't know what. I mean, it comes back to maybe the SQL. Maybe this ties back to store procedures and things like that. So if you have a call to store procedure, you bind parameters, and one of those parameters is a string. Then it depends on how the string is processed inside the store procedure. And then once again, I think I touched on this, especially with SQL injections, it can be really hard to detect if they've actually succeeded. I mean, usually in web pages, like in the if you have a page that updates the database, the response won't tell you anything about if there is actually vulnerability there. So you have to do some further research, and the same would probably go for store procedures as well.
JMS, do you have a messaging service?
Yeah, JMS, but there was JWS as well.
JWS, yeah.
What was that?
Do you have a web server for the end client?
Oh, okay. Well, then it's. Well, if it's. I don't know. Still, if that's JMS, then you should be able to.
Over HTTP.
Over HTTP, yeah. Then you should be able to use that.
Yes.
You have to check out our JMS support, which is provided by Hermes JMS, so which is another great open source product. So if that supports it, then soapUI supports it, and then you can do security tests.
We have, I think, one question that somebody asked somebody else, plus one. How can we do security testing for SOAP request enclosed in the C data tag?
It's tricky, actually. It's the same, because as it works now is that you specify an XPath statement which specifies where to insert the parameter, and since it's in the C data, you can't.
Exactly.
You can't. So my spontaneous response is that you can't. I think we have a similar issue if you want to do insert parameters like SQL injections into JSON requests, which would have the same problem because we can't index into those using XPath. So I think when we solve that problem, which we should, then we should probably look at the C data problem as well. So it's a really good point.
Yeah, here's also something I wanted to answer actually. Vinitha said, while performing the security testing for web services, can one rely on soapUI itself, or do we need to do manual testing with the help of proxies or so? And of course the answer is soapUI is not enough. Right. The soapUI doesn't take away the need for real talent, and the security testing people are necessary. So you can't replace good people with soapUI. SoapUI is just, you can't. But so SoapUI is, I mean, it's like kind of what you said initially. SoapUI is just for doing sanity checks of the security, which a tester or a a developer can do, but it does not in any way replace a talented security tester.
No.
No.
But it's a great tool for a talented security tester.
That's what it is.
Configure it to expand.
Yes.
Configure it to hammer your services in a different way, and then in a more elaborate way than the default way.
Good point. Give the tool to talented security tester, and let them help you extend the tests, so you can run it in a continuous in a CI environment and so on. Yeah, there's discussions about SQL.
Oh, the pronunciation?
Yeah.
Oh, should we have a vote?
Yeah, and Orianelli said that Microsoft people use SQL.
MySQL, people usually say that, don't they?
Let's do one more, and then we should wrap up, I think. While I'm just reading it straight now from the chat room. While performing the security testing for web services, can one rely... No, that's what you already asked.
Deja vu.
Yes. Let's do one more from the prepared questions, the ones you sent in. What did we have there? We had general, that was testing, there was a bit about SSL, but we went into that a bit, or did we?
No, I mean...
let's skip SSL,
yeah.
let's do DOS, because we had John, Abhishek, Syeda, Klaus, and Cody, and someone more I didn't get the name from, who asked about denial of service attacks. And that's something we actually wanted to talk a bit about. Basically, DOS test, can you do it in soapUI? It's like John Hoyer said, is it testable at all? Which is a good point.
I mean, there are... soapUI is not denial of service attack testing tool. I mean, if you're lucky...
Large orbital camera, what is it called?
I mean, some of the security scans, like yes, XML bomb and malicious attachments, could result in denial of service, but I think there are much better tools for that really try to... And denial of service usually attacks at a lower level, at the network interface level, or opens thousands of connections without sending any requests, or tries to exploit more vulnerabilities in other layers, not the functional application layer. That not being said that there could be there as well, but usually it's on another level. So I think I wouldn't tout soapUI as a DOS attack testing tool. I mean,
and it isn't a DDoS attack tool. There's no distribution inside it. So
no.
And somebody wanted to show an example of it. And actually we can't, because usually, I mean, what you need to orchestrate, sounds like we've done this before. We've been victims of the DDoS attacks. But basically what you need is a lot of IPs. It's really good if you have a bunch of zombie computers to orchestrate them from, and then you need a tool to control these and search for lulsec DDoS, and you'll find good links for tools like that.
You seem to know a lot about this, actually.
But the point is, I think for us when we do tests, DDoS, it's kind of a different animal, like you said. But what you can do, which is really interesting, which I would encourage people to do, is do a huge or big scale stress test, and then run security tests at the same time, because some really funky stuff can show up.
Yeah, that's a good point.
So distribute a load UI test over several agents, start running that, and then run your security test. You'll find so much cool stuff.
Weird stuff going on.
Weird stuff.
That's a good point.
Yes, Vikas asked again, will we share it? Yes, YouTube. Exactly. Thunderwolf did that kind of by mistake, a DOS attack. But for me, a DOS attack is also, it's got this distribution mechanism, because the problem is most firewalls, if you hit it with 5,000 clients, a lot of firewalls will like stop it immediately. But if you can distribute them, so you have the 5,000 clients on 5,000 different computers, that's when it's a bit harder for the firewalls to.
Yeah,
we had to upgrade ours because it couldn't take a proper DDoS attack. But it's fun. I hope you found some nice bugs in your web services when you did that, Thunderwolf. It's correct, somebody asked about Pikachu. Yep. We do have a Pikachu and a Mario.
Yeah, you can't see them, there are a bunch of the figures over here. We have a very talented person in this office builds these Lego figures.
He only works with that.
Yeah, he's a full-time employee. We feed him time to time.
Yeah. Yes, he builds
no surprise
for food.
No surprise he's talented.
Who's to the left of Pikachu? Actually, that's
that was one of our kids.
Yeah, one of our kids. No, I did that. Thanks for trying to cover, but I did that. No, it's nothing. It's one of the kids did that. Yes, let's end like Istvan Verhas says. Let's end on a happy note.
Yes.
Somebody asked if we plan to do this again. And as usual, the answer is in 6 weeks.
Yes, of course. Just
now, honestly, I don't think maybe there won't be anything more this year. But we honest have the intention of doing it every 6 weeks next year.
It's fun.
Because we enjoy it. Actually, it's really energizing. It makes working the next day so much easier. So we want to do it. I don't think we'll have anything more this year, though. Possibly.
We'll see.
We'll see. But thank you, everybody. Well,
thank you.
Okay, thank you. We
Thanks.
love you. We never tell each other how much we love.
No, I think there's a lack of love in these webinars.
Yeah.
Okay. Bye-bye.
Bye-bye.